I welcome you back again to another video lecture on Python programming, and here let's go ahead and create a simple project that will help us to dictate prime numbers and the complex numbers. Alright, so let's go ahead and kick off immediately by importing the math module. So go ahead and import math module. So import math, and that will help us to import the modules we need for this, and especially the square root, and let x be equal to, let's say, int, and go ahead and say input, and go ahead and tell the user to insert any number to check. So insert any number to check, either for prime or for complexity. Let's go ahead and say that if x is less than 2, that means if x is less than 2, this is not allowed because the numbers must be above 2 to check for the prime number and the complex. Let's go ahead and say print. So go ahead and tell the user, please insert number greater than 2. Say greater than or equal to 2. Alright, so let's go ahead and quit the program. Go ahead and quit the code. Else if x is equivalent to 2, so it means that this is a prime number. Alright, go ahead and say this is a prime number, and once you do that, go ahead and quit from the code as well. Alright, now you go ahead and check for other numbers. So like the other numbers, you have to go ahead and increment. Let's say y equal to 2, so go ahead and say num is equal to int. So we have to check the variable divisor, which will be incremented by 1 in a circle. So now let's go ahead and say int mass dot square root, and pass in the value of x right in there, because that is what we want, the square root of the number that is given. Now y, go ahead and use a for loop and say that y is less than or equal to num, to check if x is divisible by the current number. Then using an if statement, to go ahead and check if x modulus y is equivalent to 0. So that means if x modulus y is equivalent to 0, that means this is a complex number, and go ahead and print. Go ahead and print this is a complex number. Else, okay, let's quit the program. Once you print that, go ahead, once you find that, you go ahead and quit your program. Alright, and then you increase the divisor by 1. So to increase the divisor by 1, go ahead and say that y plus equal to 1. So up to this point, the program will reach if in the circle it was not determined that the number is a complex. Since it's a complex, it means that it must be a prime. Okay, so if it is not a complex, then it's a prime. Go ahead and print. Go ahead and print this is a prime number. Now let's go ahead and run this code and check it out. I believe it's something, everything being equal, it should work out very fine. Now let's go ahead and say insert any number to check. Let's say 9. This is a complex number. Okay, now let's check. 19. This is a prime number because 19 is a prime number. 97, let's go ahead and put 97 is a prime number. Let's check for complex number like 90. Wow, go ahead and put 91. This is a complex number. So I believe you can see that working out fine. Now let's go ahead and input a number. Let's say 1. Please insert number greater than or equal to 2. Can you see that? Now let's go ahead and input 2, and 2 must be a prime number. Go ahead and check it out. This is a prime number. Alright, so the code is just ready before you. Pull it down on your system and play around with it. If you have any question, please go ahead and use the question and the answer section, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture.